Today we're going to talk about a couple things, variables first, and then learn how to have our programs ask questions. This will be a programming lecture today, so I'm excited. All a variable is, you've used it in algebra class before, of course, but a variable as far as computer science is concerned, it's a little box with a name that can hold on to stuff, and you can change what goes in the box. Okay, so let's get started with that. So yeah, a variable in general is just a box. A variable is just a box. It can hold stuff, and that stuff you could use later. So like maybe you store some very large, complicated calculation in a variable called x, and then you can just say x for the rest of the program, rather than typing out that complicated expression all over again. And then you can use it too. You can be like, all right, so I made x, but compute x plus 1 now. You can do more with it, and you can use its name rather than having to type out whatever was in it, which is really nice. So it's storing information to be used later, and it just is super nice. And it's going to help us make a program that's interactive. So if we ask the user for something, we're going to get their input into a variable. And we don't know what they're going to type, but they're going to type it, and we can have it and save it for later and use it in our program by putting it into a variable with a name. And then you can calculate with it and be like, all right, what was the user's input times 2? You're making a calculator program or something. Okay, so that is a variable in a nutshell, and let me give you an example of it in Scratch, of course. So if you'd like to follow along, and I highly encourage it, you go to scratch.mit.edu. As we know and love, click that Start Creating button. Off it goes. Eventually that'll load, but yeah, I want to make a program that says that prints not hello world anymore. I did that on the first day. I want it to print hello, your name. So let's have the Scratch cat ask us for our name, and then it'll all work out. I don't know why this is taking so long. Maybe I should just close my browser and open it again. It's trying very hard. I feel like it's not trying hard enough. There it goes. Okay, so I like the Scratch cat to ask me for my name, then we'll save it. Save it in a variable so that you can next say hello Lawton, or hello whatever your name is. Okay, so that's the idea. We're going to hold on to information, and we're going to get it for later. All right, so first of all, we are going to compute. The Scratch cat is eventually going to say hello plus our name, and our name is going to be in a variable. Okay, it's going to be in a variable called the default name in Scratch when you get something from the user. So I put my name, I type it in, it goes into this answer variable, and our goal is to generate a string that has hello, comma, space, and then my name, and then an exclamation point. All right, so I have to shove my name into whatever the Scratch cat says, and I'm making some text. All right, I want the Scratch cat to say all this, and text, as far as computer science is concerned, it's called a string. All right, so a string is just a bunch of characters, one after another. You can think of it like beads on a friendship bracelet that you take to the Taylor Swift concert or something like that. It's just a string of characters. That's what we say stuff in quotes are in computer science, right? So a string, for example, the string 1, 2, 3, if I put the number 1, 2, 3 within quotes, that's just characters. It has nothing to do with numbers. It's not the same as just the number 1, 2, 3, okay? So that's important. We'll get there. And the reason I'm bringing this up is that, depending on what you have, depending on whether you have a string, whether you have a number, you can do different things. And those things are called types. All right, those different classes of things you can have and do on them are called types. So, the type of 1, 2, 3 by itself, just type out the digits, not within quotes, is a number, right? And then what can you do to numbers? You can, I don't know, you can add them, you can multiply them, you can do math on numbers. You can't do math on strings. It's just words, right? Just characters with no meaning, all right? So those are the different types, right? So a string, if you put 1, 2, 3 within quotes, it's a string. You can print out characters, that's fine. And then you can, make bigger strings by joining other strings together, and we'll talk about that. But I just want to, plant the seed of this idea into your mind. Every variable, when you make one, it has a type, and so, for example, this type, it's just a bunch of characters, it's a string, right? So I should put it within quotes. So that's very important, and it will come up later in when we talk about Python. But all right, did anybody see the block, one of these, that like asks the user for something? It's here somewhere. Anybody find it? It's not motion, that's for sure. We have saying stuff. What is there? What else is there? Scroll and scroll and scroll in. Events, maybe? Control. It's down here in sensing. See it? It's the ask block. So if you run this block, you give it a little prompt, and I'll just click it to run it right now. You click it, it runs, and it asks what your name is. And then you can type whatever your name is, hit enter, click the checkbox. And then it got it. It got your name, and it put it into this special variable called answer. You see how this is just a little oval? It's not code. It can be part of blocks, though. So this is a variable that holds on to stuff. If I click it, I get to see its current value. So it just got set to Lawton. All right. If I click this block again to rerun it, and I type my cat's name, then now it's reset the value in this answer variable to whatever I just typed again. See that? So I can use this variable to do cool stuff. All right, so let's make this a bit more normal. When the green flag gets clicked, ask for your name and wait. My name is Lawton, hit enter, and now the answer variable holds onto my name. All right, and so what I want to do is calculate, I want to calculate the string hello, comma, space, your name here, and we're going to do it with join blocks. All right, so this is how you do it. Answer is a variable. It holds whatever you just typed from that ask block. So like maybe right now it holds my name. Maybe it holds yours on your computer. And we need to compute a bigger string. Like Lawton is just part of the output. We want this whole thing, right? Hello, comma, space, my name. And so to put strings together, you can use this join block. All right, it's down here in operators. So it's joining two strings together, and it'll make a bigger string. So this is apple and then a space, and this is banana on the right. If you click it, it runs it and shows you what it's going to compute. It computes the bigger string, apple, space, banana. Does that make sense? So like if I want to say hello Lawton, comma, space, Lawton, be like hello, answer. You do need the spaces though, right? Spaces are not implied. So like this is just hello Lawton with no spaces right now if I forget them. So I want a comma, and not just a comma. So like now it's still missing the space as it's computing it. I would like comma space, please. All right, does that make sense? It's computing that bigger string, and then I can have the Scratch Cat say that back to me. So that's in looks. Say something for 2 seconds. Notice how the things you can say, that's an oval. I can drag bigger things into there. So it's now going to say, after it gets my name, hello, comma, space, Lawton for 2 seconds. Does that make sense? Any questions about that? Because we also want the exclamation point at the end now, right? So how in the world will we ever do that? I guess I gave you the answer here. You just need 2 join blocks. Okay. So the first join made hello, comma, space, Lawton. Let me bring it back out. So that one made this. Hopefully you can see that. And then all we want is to take whatever that was, boop, and put an exclamation point at the end of it. See that? So that's one way to do it. And so that'll compute hello, comma, space, Lawton. There is an alternative, though. You can do it. There's a different way. You can do it this way instead. Oh gosh, not that way. How do I want to do this? It again uses 2 join blocks, but you can do it this way instead. You can be like, you can do the hello, comma, space first, and then you can compute Lawton exclamation point second. All right, so this is like Lawton exclamation point, and bring that in here. You see how both of these are going to be equivalent? Either you can put the exclamation point first and then shove hello at the start, or you can say hello and then shove the exclamation point at the end. See the difference between these 2 join blocks? They're going to compute the same string, though. Any questions about that? That's a little subtle. We good with that? It's down in operators in the green. It's underneath the pointy stuff. Join right here. So you can pick any one, but I'll do that one. And we can say it for 2 seconds. So click the green flag. Or here, let me bring this up so that when you see it, when you download this code yourself, you'll see both options. So what's your name, Lawton? And then it says hello, comma, space, Lawton for 2 seconds. Or if we pretend to be my cat, it says hello, comma, space, Lonzo for 2 seconds. Does that make enough sense? Not too horrible. So let me save this. I'll give it to you later. Oops, that was... Oh no. Wait. Okay, cool. We're good. We're good. Never mind. Save to your computer. It's going to go to a weird place otherwise. All right, so that's my first program for us. Let's now get not string input. Let's get number inputs. So let's make a program that computes the absolute value of the user input. All right, it'll be not too horrible. So let's ask the user for a number this time. We're going to get it into the answer variable. Like maybe they type -42 and it's going to be put there. It'll be a number. You can do number stuff with it now. And then we will output the absolute value of that number. And maybe just to make it fun on ourselves, let's like have it start in a different way. Like when the scratch cat gets clicked, I'll have it start the program rather than when the green flag gets clicked. So let's do this. So I'll make a new program, change everything. So we'll say ask, I don't know, not what's your name, but like enter a number. And like put a colon there, so like there's a cute prompt or something. I don't know the best way to do it. Enter a number, exclamation point, whatever you feel like. And then we'll get that number and it'll be placed in this answer variable. Does that make sense? So like if I enter a number 42, it'll have been placed in the answer variable. If I enter a number -42, it'll be placed in the answer variable. It just keeps getting updated with whatever was there. And I'd like this program to start not when the green flag is clicked. Let's have it start when the sprite is clicked. And remember that the scratch cat is your sprite. So now when I click him, he says enter a number 42, answer holds that. And I just need to compute now the absolute value of that number. So if it's negative, it needs to become positive. There is a block for that. It's one of these. It's the abs block way down here. There's more to it. There's more than these that you can choose. Like this is a bunch of operations in one. You can pick which one you want, like sine, cosine, tangent, all that fun stuff. But like absolute value, that's there. It's just called abs. So abs of answer. If, for example, let me click the sprite, run the program, -42. So now answer holds -42. The absolute value of -42 computes +42. Cool. So let's print out that answer for 2 seconds. And you can make it pretty. You can like join some strings together, be like the absolute value of blank, put in answer is, join it with the absolute value of the answer. But we'll just make it easier on yourself. So I click the green flag, nothing happens because this program starts when the sprite is clicked. 42, 42, -42, still +42. Okay, so there's that one. Yeah, not too horrible. So that's doing math on your input. We good with that one too? Again, slowly increasing the difficulty. Let's talk about making your own variables, because like answer's cool. Like answer's there. It's whatever you get from the ask block. But like let's make our own variable. Let's have it be called x. All right. So let's make a variable that increases whenever I press the space bar. So that'll be a cool program. So like maybe it starts at, I don't know, some value. I don't know, 42. And then we'll have it be incremented every time we press the space bar. So 42 becomes 43, 43 becomes 44, something like that. All right. So I'll show you this code. I guess I'll put, like, instead of 44, I'll put 42 at the start. But let's get there first. So new program. Down here in the orange section, variables, you have variables that you can make. There's a default one called my variable made for you. You can right-click and rename it, or you can make a brand new variable, whichever you prefer. I'm not going to use this my variable, so I'll just rename it to x or something. So you can call it whatever you want. And so now it's called x. Okay, so there's that. Let's see. So here's some operations on x. Like by default, when you make a brand new variable, like it holds 0, holds nothing. That's like its default value. But you can change it whenever you want. Like you can say there's a set block, set your variable x to something. So like 42. If I run this, clicking it to run it, now x holds 42. And then this change block will change x by incrementing it. So change x by 1 means make it 1 bigger. So it was 42. If I click this block to run it, now x is 43. If I click it again, now it's 44. Yeah, you can change it by -1 to go in reverse order to make it be smaller. So that's fine. What else? And then there's like a show block to like look at the variable, show. So like it puts it there, show variable x. Okay, so that's the idea. That's what's going on there. You can also just click this checkbox to like always show it. Show it or hide it. Whichever one you feel like. So, yeah, let's do this. So let's make a program that sets x to 42, shows it, changes it by 1, and then shows it some more. Yeah? Does that make sense? And then I'll make this program start when the space key is pressed, because why not? So when the space key is pressed, let's run all this. Okay, so I'm going to press the space key right now. What it's going to do is going to set that x variable that I made down here. It exists. 242. It's going to show it. It's going to change it by 1 to make it 43. And then it'll show it again. So I press space. Boop. Boop. I'm running it a bunch of times. It is always showing me 43. So that's a little weird. What's going on here is that all these blocks, like there's no waiting involved, right? It wasn't like do something for 2 seconds. It was like just do it. And computers can do things very quickly. Like you have a 2 gigahertz processor, it can do 2 billion instructions, 2 billion operations per second. So if you want to see something and watch it change, you should add like a wait block into your program. Okay? So here we go. Let's do that. If you want to like watch it change from 42 to 43, like let's wait in between here. Does that make sense? Because otherwise it's going to do those things essentially instantaneously, faster than the screen can refresh. All right, now let's watch it. 42 becomes 43, yay. 42 becomes 43, awesome. 42 becomes 43, yay. So that's a little bit better. If you actually want an incrementing program, let me do that too for you. Let's be like when, I don't know, not when space is pressed, but like when the up arrow is pressed, let's say. Then just like change x by 1. It's already being shown, so like you're good there. If I press the up arrow now, watch it go. 42, 45, 46, 47. I can hold it in, like it'll change it very quickly. So that's another way to do it. But space key is going to do that program, 42 to 43. And now we've waited a little bit so we see the change. But this other program, just up arrow and it changes x immediately. Cool. Any questions about either of those? So programs can start when you press different keys on your keyboard. That's not horrible. Okay. So with that, show you that. Save that for later. What our programs look like right now are this, right? We got some event to kick everything off. Whee, looks like that. It's like event. That's the kind of event block. And then you just put a bunch of blocks below that. This is what our program looks like right now. Do thing A, do thing B, like thing A, do it. Thing B, do it. Thing C, do it next. Thing D, do it right after that. So the way our program's going to run right now is like, all right, first do A, then do B, then do C, then do D, which is a little boring. Yeah. Wouldn't it be nice if you could do, there's some options you don't have right now that I haven't shown you how to do yet. Wouldn't it be nice if you could do this? Start with A, rainbow for effects. Start with thing A, and then like depending on something, like either do thing B or thing C, and then maybe come back later to thing D. That'd be cool. Like either go this way or go this way, depending on like user input maybe. That would make for a better program, a cooler program. So that's the thing. That's called a branch. You branch off and you do one thing or another, and then maybe you can come back later to do more straight line looking stuff. That's totally fine. And then there's another one called a loop. So wouldn't it also be nice if I wanted to repeat stuff? Like if I want to do A then B a bunch of times, like right now I just have to like add another A block down here, add another B block down here. Instead of that, wouldn't it be nice to be able to do this? Have our program come back to previous blocks. That's another thing we don't know how to do right now. Okay, that's called a loop. So let me show you both of these today. All right, make for cooler programs, very powerful things. So let me make a program. Actually, loops are the easiest thing to teach you right now. Surprisingly, if you take CSCI 40, I'll do it in the opposite order. But I can teach you loops easier than I can teach you branching in Scratch. So here is a fun little example of loops. So I'm going to make a program that like makes the Scratch cat very dizzy. Loops example. We are going to make a program that starts, again, when the up arrow is pressed, because why not? Like we're shoving the Scratch cat up into the air. And so we're going to ask the Scratch, or we're going to have the Scratch cat ask us with an ask block, how fast should I spin? We're going to give like a number. And then we're going to repeat something. Repeating turning a bunch of times, all right? So this lives in control. New. Control. There are loop blocks. One is a repeat 10 block, and do you see how it has a section inside of it for stuff? And that will repeat that section some number of times, 10 times, 100 times, 1,000 times, however much you want to go. Default is 10. But here's the idea, like this is a block, this is a loop. Repeat is a looping block. The 10 is how many times to repeat the code that's on the inside. Number of times to repeat the inner code. And then whatever you put inside, you can put multiple blocks inside, just a big long thing. This will get run that many times. So this exact block right here is going to get run 10 times. Gets run 10 times because it was a repeat 10. Okay. So that's pretty cool. Let's make that program. So when the up arrow is pressed 10 times, I'd like to do something. Or let me like break it down for you first. So we're gonna have the Scratch Cat ask how fast you want him to spin, because like he's cool like that. And then the idea is we're gonna repeatedly turn a certain amount. See how if I click turn 15 degrees, the Scratch Cat turns a bunch of times, or turns 15 degrees. If I keep clicking it, he keeps turning. That's kind of where we're going with this. And so depending on how big this degrees is, right, if it's 25 rather than 15, see how if I click it, he moves a bit more. He turns a bit more each time. So that's going to lead to animation. So depending on what we ask how fast should I spin? In the answer variable, we're going to put a number there, right? And we'll use that number as how much we want to turn each round. We're going to do it 10 times, all right? So if this number is small, like 15, he'll repeatedly 10 times turn 15 degrees, and then like every time you run this block, it takes a little while to like move the Scratch Cat. And so you'll see animation. But if we asked the Scratch Cat to move like 35 degrees at a time, then he'll move farther and faster each time because it's like clicking the block 10 times. 10 times as fast as the computer can click it. Okay, so let me click the up arrow. How fast should I spin? Let's do 15. Whee! And so it ran that block 10 times, this inner block 10 times, and it moved him, I guess, 150 degrees total. So up arrow again, let's do like 15 again. Boop. Up arrow again. If I do like 5 at a time, it's going to run the block turn 5 degrees down, right? Because answer's holding 5. And he'll move a bit slower. See that? Because he's moving less degrees every time. If I say move like 25 at a time, like he's going to get really, really dizzy. 35 is going way too fast. Yeah? And so you can control the spinning because it's like clicking this block 10 times and it's waiting for the Scratch Cat to move. And so that takes a little bit of time and produces animation. You can't get it to work? I don't understand. Drag the answer into the symbol there. Oh, not there. There you go. And you are in the program right now. You have to type how fast you spin. Yeah. Either click enter or type the checkbox. Yeah, I think you're running it too many times right now. It should work. That should do it. Any other questions about this one? I'll come help you during an in-class question. Let's see here. If we're good with that one, that produces fun animation. Save. Now I want to teach you about, that was a loop. I want to teach you about branching. And to branch, you need to ask a question. Because it's like, do I do this thing or do I do this thing? It's depending on like the answer to a question. Yes, no question. Okay? So we would like branching to happen. Remember what branching is? It's like go off and do one thing or another. And so how does that work? It's got to depend on something. Like input, for example. So like if the user typed, I don't know, into the answer variable 42, if the answer to that is yes, if the answer is yes, I mean, if answer is 42, is a yes answer or a no answer? So is answer equal to 42? In the yes case, do thing A. In the no case, do thing B. That's kind of what we want to have happen. And then like, all right, then you're done with one or the other. You can go back to like your straight line code down here. This right here, the thing that splits it off, the question, that's called a condition. That's another word for that. And that's going to make it work. Okay? So we need to be able to ask questions, and like, if the answer is yes, we'll do one thing. If the answer is no, we'll do a different thing. That's what we're going at right now. And so to get there, we need what's called a Boolean, which is derived from that dude named George Boole that we talked about on the first day of class. So Boolean, I'll say bool for short sometimes, are values that you can compute that end up being either true or false. All right. In computer science, yes, we don't say yes, we say true. And we don't say no, we say false. All right? So it's like you ask this question in your program, and it's like, in the true case, do thing A. In the false case, do thing B. Okay, that's where we're going. So yeah, let's have that happen. We like to be able to do something if the question's answer is true or false. Okay. Sometimes just one. So here's the idea. Let's make, as our first example of a branch, let's make the absolute value. Let's perform the absolute value computation without using the abs block. All right? So I'm going to have you try it in a second, but I'm going to teach you how to do it. All right? So here's the setup. Look, so like the user, maybe they type, I don't know, if they type the number negative 42 into the answer variable, yeah? You would like to make it positive 42. And here's what you would have to do if you didn't have the abs block, and this is what I'm forcing you to try. So you got to get the input first, like ask the user for a number. That's the first thing you got to do. And then you got to check, is the input less than 0? And the blocks that give back yes and no answers, true and false answers, they're pointy in Scratch. And so I'll write that in a pointy way right now. And so you're going to have to ask this question, is the input less than 0, question mark. Scratch can figure that out for you. And then depending on the answer, if the answer is yes, we go to the true side, the true branch, we say. If the answer is no, you go to the false side, or the false branch. Okay? If the input is less than 0, what do you got to do to this answer before you show it? Because the answer is, you shouldn't just print out negative 42, right? You have to multiply it by negative 1 if it's ever negative. Multiply by negative 1, that's how you make it positive, right? And then you're ready to display whatever you just computed. Show that. That'll compute positive 42 from negative 42. Yeah? But if the input is not, right, if this is a no answer, if it's false, if the input is not less than 0, that means it's already 0 or positive. You should not be multiplying it by negative 1 because that would make it negative, right? So you can't go down that side. You're just ready to immediately display that number. The original number that you got. So like if it was just 42, then just display 42, yeah? So do you see how you got to pick the right side to go down, because otherwise the answer will be wrong? So if the input's negative, you got to do this side. Multiply it by negative 1, then show it, because that'll make it positive. That's absolute value. Otherwise, if it's not negative, it's already good. Just display it. You're good. Good to go. Okay, does that make sense? So the way to make this happen in code is to use the if-then-else block. It looks like this. Also in control. So I'll make a new file. Also in control is if-then-else. And you see there's a spot for pointy stuff. That's where the question's going to get asked and answered. All right, so this is how this block works. You put your condition here. That's where it goes. Condition goes here. Condition goes here. It has to become something that must eventually become true or false, because that's going to guide which side to go down. Must become true or false. And just by virtue of using pointy blocks, that's always guaranteed for you in Scratch, so you're good. Just use pointy blocks, it'll be fine. And then you see how there's 2 slots here. See that? There's 2 slots. There's a then slot and an else slot. The first one's the true side, the true branch, and the second one's the false side, false branch. All right. So this code you can put many blocks here as you want. This will get run or executed if your condition is true. Okay, and we call that the true branch. True branch. Let me spell that better. Okay, and then this one, if the condition was false, then you're going to skip over the true part and you'll run the false branch. This is executed. It's only one or the other. If cond is false. That's how it runs. All right, let's call it the false branch. Okay, so the idea is like this block corresponds to this kind of code. It's like first you have your condition, you check it. Is it true or false? Depending, you do stuff number 1 or stuff number 2. Okay? And then once you've picked a side, you can put normal blocks down here, as many as you want. We'll just hook in, like, after this is all done, it's picked a side, just do more straight line blocks if you want. Alright? So that's how that runs. And the pointy stuff is in operators. It's like, here's like a less than block, for example. Is 1 less than 50? Click on it. See how the answer is true. Is 55 less than 50? No, the answer is false. See that? So let me just show you an example here. Let me just say, I'll say true branch and false branch. And then you'll watch it work. So this one, 50, if the condition right now, it's always false, right? So if I run this, it'll run the false branch. So it's saying false branch. See that? Now if I make it say, hey, check if 5 is less than 50, that'll be true, so it'll run the true branch only. Any questions about how the if-then-else block works? And that's the secret there. And so, dun dun dun, your job now is to take this with the if-then-else block, try to make it work. Try to code this up. Absolute value without the abs block. Okay? So, if you get this done quickly, you're going to get that number from the user first, right? With the ask block. If you get it done quickly, try to use your own variable instead of using answer, because you can't change answer. You can change a variable called x, like place the answer variable into a variable called x or something, and then you can mess with it. You can be like, set x to be whatever x was times -1. That's possible. So if you do the normal way first with just using answer and multiplying it by 1 in the output, try to do it this way. Try to bring the value into a new variable and reset that variable to get practice with. Okay. So I'll give you several minutes to give this a try, and then I'll show you my answer. So please get together with the people next to you and help each other. See if you can get it working, computing the correct absolute value. And then I can help you if you're still struggling with that.
Yeah. I don't want to show it. Really, get the answer.
Oh, okay. Let's see here. Just drag an ask block out there and click it, because I have a feeling just like the ask block is not running.
Just like this.
Yeah, drag an ask block just out into the ether, out into nowhere. That was in blue sensing. Like, so just click it and like type your name or something. That should work. Now drag an answer variable out somewhere and just like click that too. So it is getting it. Okay, so now do you want to make the program from before? So now it's running that block, it's waiting for your input. It's asking what's your name right now. You have to enter it in order to complete running the ask block. See how it's highlighted? It's running the ask block right now. It's waiting for your input. You have to finish inputting, and then it finished running the block.
Okay.
Does that make sense? And so that's what should have worked from before. Do you want me to just quickly recreate the old program and see if it works now?
Yeah.
So it was like, how fast should I spin? And it was like, I forget what started it. It was probably like the green. It wasn't the green flag, but we just have it. When the green flag is clicked, tap that should spin. And then we're going to repeat 10 times spinning by that amount. Motion, turn right, by amount. And so if we run this, green flag clicked, it'll run all this stuff. So it's waiting on the ask block. How fast should I spin? 15 or something. Goodness. I have a feeling it's just like it was still on the ask block and you weren't done typing or something. Yeah. So you can just use the same block, like in the first stage, like say, and then you drag the answer you want to say into the say. Does that make sense? Yeah. Yeah. But remember to use an ask block first to get something into the answer. It's got to be ask block, then if then else, I would say. So in my drawing, input would be called answer, right? Because that's the special variable that you're forced to use. I'm going to take another few minutes to play around, help each other, and also ask me questions. Let's see if you can get it yourself. And I'll show you how I might do it. Hold on, did we all do attendance by now? Please do that. I'll stop that after all this, after this question, if I remember. Alright, that is my timer. Did any questions come up as we were trying this ourselves that will not be answered by me doing it for you? Alright, let's see here. So, alright. Here we go. We gotta get input from the user. I don't know the best way to do this. This is a brand new program, so let me just drag it. Let me make it blank. When the green flag gets clicked, let's ask the user to enter a number. So that's in sensing, the ask block. Enter a number. Enter a number and wait. And then depending on the number, which will be placed in the answer variable, we're gonna do one thing or another. So if something involving the answer variable, then we're gonna output stuff. Alright, so what we want to do is we want to check, hey, is that input, which lives in the answer variable, is it less than 0? And that'll be a true or false thing. So I'll drag less than, is the answer less than 0? I'll put that right into the condition there. So if it is, it'll run the true branch, which is the first whole thing. Otherwise, if it's not true, that means it's greater than or equal to 0, right? Then it'll run the other branch. All right, so if it really was less than 0, that was true, I want to multiply by -1 before I show the answer. Because I got some work to do, right? So I don't just want to say the answer for 2 seconds. I want to say negative the answer, right? Because if it was negative, multiplying it by a negative makes it positive again. So that's the star block. Take answer, multiply it by -1, say that. Yeah? Otherwise, let me duplicate. Otherwise, you can just say the answer. Just like don't even, oops, stop. Otherwise, just say the answer because it's already good, right? So if the answer is negative, I'll leave a comment here. If answer is negative, negate it before outputting. Otherwise, this is the other block. Oops. Otherwise, if it's already positive, if the answer is already positive or 0, just keep it as it is. Okay, those are my 2 comments, and let's watch it work. So enter number -42. It outputs positive 42 because this was a true statement for that number. It was less than 0, so it's going to say answer times -1, which is going to compute -42 times -1, which is positive 42, and say that. Okay? If I rerun it and I say positive 42 as my input, it will still say positive 42 as the output because this is false now. It is not less than 0. The answer is no, so we'll run the else case, which just says whatever is in the answer variable. It's not going to touch it this time. Okay? Any questions about that? That's how I would do it. And with that in mind, I promise to stop the attendance. With that in mind, let us talk about doing it with an extra variable. Because you can do some cool stuff to variables. You can mess with them in weird ways. So let me redo this program. And I'm going to use variables instead. So I'll make a separate program over here to the left, maybe. And we'll do it like when the space key is pressed, we'll run this secret other version of this program. So a lot of it's going to be the same. Right? I'm still going to ask for a number. I'll delete the comments though. Still going to ask for a number. But then, instead of using the answer variable everywhere, I'm going to shove that number into a variable that I make for myself. I'll put it in a variable called x. So I'll rename this default variable. Right-click, rename to x or something. You can also make a new variable by clicking that. So before I do any of this, I want to work with x rather than answer. So I'm going to set x to be whatever answer was. So that's how I shove the value, whatever it was, into x. You see that? That's how I do it. So now if I type -42, now x holds -42. See that? I just placed it into x. And now I can just change all these. Like instead of asking stuff about x, answer, I can say do stuff with x. X. All these x's all over the place. And so that'll make the program work again. That's fine. Now we're just using x rather than answer. So I'm going to press the space key, -42, positive 42. Cool. Space key again, positive 42, still positive 42. So it's just working with the x variable. But I like to go even further. You can mess with variables. You can change them on the fly rather than just using the change block. So you can reuse the setting. All right, so here, watch. I could say if it's less than 0, Don't say anything. Don't say anything. If it's less than 0, I would like to set x. I like to change it to be whatever it was. Watch this. This is a little weird. Whatever it was times -1. Isn't that fun? So if x was, I don't know, let me set the answer variable to something. -42. So answer holds -42 right now. Let me check x right here. X holds -42 because I placed it in the answer. If I run this block right here, if I click it, it's going to set x to whatever x times -1 is. So it's going to compute this, which is positive 42. Right now, x holds -42. I'll click it. Bam, you see it change? I've just changed it to something else. Isn't that nice? You can overwrite variables. Not just like cross it off, do it again. That's how that's working. Okay? So, actually, you could do it this way. You could write your program this way. You can be like, all right, if x is less than 0, set x to -1, do nothing if it's already positive, and just at the end of the day, or maybe I should say it this way. Watch this. I'll lead up to this idea. So say now x for 2 seconds. Duplicate. Say now x for 2 seconds. Isn't that nice? I've kind of got the same thing in both places. So watch it change. So enter a number, -42, positive 42. All right, space again. -42. It is less than 0. It made x eventually positive 42 after placing -42 into x. So it's positive 42. It's fine. Are there any questions about how this program is working? It's changing that variable. All right, because now there's something interesting about this, the if and the else. They have some blocks that are the same. See that? This block has been duplicated. I could actually unduplicate it by doing this. See that? If x is less than 0, just set it to its negative version. Do nothing if it's already positive. And then just after all that's been finished, just whatever x is now, say it. Yeah? That has one less block. Okay? -42. It's always going to work. And do nothing in the else case. Positive 42. Just doing nothing. So if you want to do nothing in the else case, just like only do something if it's true, there is another if block for that. There's just an if block. You see that? So instead of this one, let's drag it over here for posterity. Oh no, never mind. So instead of that one, I can just say this. If x is less than 0. All I want to have is something to happen if it's negative. So if x is less than 0, set x to be whatever it was times -1. So that is a bit cleaner. You just want to do something only if it's true. Does nothing if it's false. Where do I put this comment? There. Do nothing if the condition is false. There is no else for this one. Alright, see that? So now when space key is pressed, type in -42, it runs this thing, sets it to positive 42, and then once it's done it says it. Otherwise, if I type positive 42, it skips over this, because this will be false now, skips over it, doesn't run the inner side, and then it just goes straight to say whatever x was. Okay, so that is, if you want to use separate variables, that's probably the cleanest way to do it, if you want to mess with them. Any questions about that code? Okay, so I'll save that for you, give it to you, so you can have it and try it out on your own. And now I would like to introduce your next programming assignment, because you got one due. Let's talk about the next one. So here I'll release it. Programming assignment 1, because they started at 0, of course. So if you're in the camp of students that have never programmed before, here's your assignment. All right, you're going to teleport the Scratch Cat magically. All right, so here's what should happen in your program. So when the sprite is clicked, it doesn't have to be the Scratch Cat, but when that sprite is clicked, the main character in your program, when you click them, your program must do the following. All right, you have to make the sprite magically appear in a random place on the screen. There's some blocks with the word random in it that you should look into. And let's see what else. I got to be over here. And then I'm forcing you to branch. forcing you to have a condition, forcing you to have an if-then-else block. So I want you to say something silly. Look at where your sprite just got transported to. So you're going to click the sprite. They're going to be teleported to like over here or over here. And you know there's coordinates, right? There's a coordinate system for the Scratch Cat. If he's down here, like the y is negative. He's up here, the y is positive. So there is a y equals 0 line somewhere. And that's what you're going to be checking for. So if you click your sprite and they magically teleport above the y equals 0 line, have them say something to that effect. Just be like, I'm in the upper half, I'm above the middle, something like that. This is me forcing you to use a condition, right? I'm in the upper half. Or if you click them and they magically teleport to down here or something, have them notice that and say, I'm in the lower half of the screen. All right, and then maybe you click them again, they go back to the top and they say, I'm in the upper half now. Okay, but every time you click the sprite, make them go to a random place, teleport there, and then say something like, I'm above the middle, or I'm above the y equals 0 line, or I'm in the top half, something like that. If they get teleported above the y equals 0 line, or say that they're below if they got teleported below that line. All right, so that's kind of the setup. Does that make sense, first of all? Still good? And then there's also more cool things that you can do. Like you can play sounds in Scratchland. There's like you can play a little pop every time they teleport. Maybe that's the thing. I think it's in sound. There are plenty sounds. Here it's like it's a meow sound for the Scratch Cat. You can also record your own sound if you want to record you clapping or something. That's like them popping. But different sprites have different sounds. Okay, so I encourage you to play around with that. I think it would be fun. But your hard and fast requirement is these things. Sprite better go to a random place and better notice where they are, upper half or lower half of the screen. All right? And so the other requirements are you have to use a block that uses the word random in it, because that's how you teleport to some random spot, right? And you have to use an if-then-else block. Okay? So that is that. Feel free to add sound. Here's a little video example. If that didn't make any sense at all, I'll mute myself. But like here's me running the program. I'm hiding the code, of course. But like you click the sprite, they're going to teleport to a random spot, something like that. Okay, and so I've not given you the full program. I made it work when you click the green flag. Don't do it that way. I'm just showing you like how it would work if that was how you did it. Right? To get full credit, it's got to be when you click the sprite. Okay, so that's just an example of how it should work. Not giving the full answer away. Okay, so yeah. Here is how I want you to turn in your assignment. All right, this is going to be different. So I would like you to upload a video, please, of your program running, because that's how I can see it working, right? I need to see this working in every way. So I'd like you to upload a video of your program running, also with your code visible. It doesn't have to be long, just be like 30 seconds. Show me your code, click it a couple times, show it above the line, below the line, show me that it's working in every way that it should. You can record it however you like. You can record it with your phone if you need to. Zoom has a screen recording feature. I use a program right now called OBS. It's very useful. I can help you. But I'd like you to upload a video as proof of you completing this assignment. That's what will be great. Okay? So if you can't this time upload a video, then I will allow a screenshot for this assignment. All right? I need to see your code, though, so I can confirm just in my mind that it's going to do the right thing. Definitely, if you can't get it working and you have to upload a screenshot this time, come to my office hours, ask me questions after class, because I'm going to require video recordings from the next assignment onward. Okay? Questions about that? How you're going to turn this in. Show me it working. Doesn't have to be a long video, but I want you to show me that you understand it. Show me what's going on. Okay? So if you're in the camp of students that have already programmed before, and I haven't given you a custom assignment for this assignment yet, then let's talk about what you need to do. So I'd like you to read these chapters of this book, the book that you did last time, and please do exercise 5. So that should be a fun one. I think you're also going to, this might be the picture making one, I can't remember, but also please record a video of you explaining, going through your program, showing me how it works. And then just contact me if you want something custom. So yeah, that's what you will do if you've already programmed before, and this will be due on the 1st. So like you got your first assignment due tomorrow, and so like every Thursday will be like a programming assignment due date. So a week and a day from now will be when this is due for most of us. Okay, that's programming assignment 1. Any last questions about that? All right. If I have given you a custom assignment and I only told you what to do last time, you gotta talk to me again if you want to do that custom thing again. Okay. So I think that is all that I wanted to say. You got the assignment. The rest of the time is yours to ask questions and get started.